Planetary Defense, presented by Science at NASA. Dinosaurs were fearsome creatures. Some had thick scales, sharp teeth, and in many cases, lightning-fast reflexes. One thing they didn't have: a planetary defense office. When an asteroid targeted Earth 65 million years ago, it took those masters of Earth by complete surprise. While we know of no large object that is on a collision course with Earth in the next 100 years, descendants of survivors from that catastrophic impact are determined not to make the same mistake. In 2016, human astronomers now routinely scan the heavens for signs of potentially hazardous objects. When one is discovered, alerts are issued to observers around the world, so space rocks cannot easily disappear into the blackness of space. NASA-funded survey projects have found 98% of the known catalog of almost 15,000 near-Earth objects. Asteroids and comets whose orbits periodically bring them within 30 million miles of Earth's orbit. The list is growing at a rate of about 1,500 per year. Meanwhile, researchers are giving serious thought to an even bigger problem. What would we do if a dangerous asteroid is discovered? How will we know if and when it will impact? Is it possible to deflect or destroy it before it reaches Earth? All of this work, from discovery to tracking to potential mitigation, is being done by a sprawling network of government agencies, private and public universities, and both amateur and professional astronomers. Helping them work together is the job of NASA's Planetary Defense Coordination Office. Lindley Johnson, Planetary Defense Officer at NASA headquarters in Washington, D.C., says, "Planetary defense is a team sport." This office was established at NASA headquarters to coordinate the players in planetary defense-related activities across NASA, other U.S. government agencies, and with international efforts and projects to detect any asteroid impact hazard and plan the appropriate response. A recent real-world example illustrates how all this works. Paul Chodas, manager for NASA's Center for Near-Earth Object Studies at the Jet Propulsion Laboratory, describes what happened. The object was first detected by the NASA-funded Catalina Sky Survey near Tucson, Arizona on October 3, 2015, and tagged as detection WT1190F. Within a couple of days, astronomers suspected it was probably an artificial object. It was faint and small, with its motion visibly altered by the gentle pressure of sunlight, a bit like a solar sail or perhaps a hollow rocket body. As tracking data accumulated from multiple observers, astronomers realized that they would get a closer look. This would be a real-world case to exercise the team's skills. WT1190F was predicted to hit Earth on Friday, November 13, 2015. Orbit calculations by JPL analysts pinpointed the impact time and site. WT1190F would burn into the atmosphere off the coast of Sri Lanka. For years, Peter Jeniskins of the SETI Institute, working with NASA's Ames Research Center, has been leading teams researching entry dynamics on airborne campaigns to observe objects ripping through Earth's atmosphere. In 2006, for instance, they recorded the return of NASA's Stardust Sample Return Capsule with its cargo of cometary dust. They've also observed a number of defunct spacecraft re-entries and a few natural meteor events. Supported in part by the United Arab Emirates Space Agency and the International Astronomy Center, Jeniskins assembled a group of experts to witness the re-entry of WT1190F. They flew to the Indian Ocean on a G450 aircraft armed with cameras and spectrometers. Exactly at the time and place predicted by NASA's Near-Earth Object Observations Program, WT1190F produced a magnificent fireball in broad daylight. Jeniskins says the spectra of one large fragment contained bands of titanium oxide and a line of hydrogen, so the object could have been a titanium-walled vessel containing residual fuel. Chodas, who had been attempting to reconstruct WT1190F's past orbital motion, says, "My educated guess is that it was Lunar Prospector's Translunar Injection Module, which had a titanium case, although we may never know for sure. One thing is certain. Astronomers supported by NASA found it, tracked it, and predicted where it would hit with pinpoint accuracy. These are exacting skills that will come in handy the next time an actual asteroid comes to visit." For more about asteroids and NASA's planetary defense capabilities, go to www.nasa.gov/planetary-defense. For more on objects both near and far from Earth, stay tuned to science.nasa.gov.